So please stop doing that. Stop any worksheets you're using. Miss Megan and Mr. Jovino, I'm sure they speak English. Thank you. So today we want to discuss angles of elevation and depression. This is another way we apply the trig ratio. Again, this is still about right angle triangle. Now, I'm not saying there are no special questions on angle of elevation and depression that are not related to right angle triangle. But we are only focusing on right angle triangle for now. If the triangle is not right angle, the approach to use is the next thing we want to learn. So I'm trying to arrange it in that sequential order. That's some please do not sleep in my class. Now, the first thing we want to do is, what are these angles of elevation and depression? Maybe if we understand them, then we can apply them in real life scenario. Am I making sense? And this is how I explain to everybody, including Form 5. And hopefully, I'm able to, give you all the explanation you need with this explanation, with this illustration. So, a normal human being is expected to stand and look which way without actually complaining about my neck hurts or whatever. Which plane do you make contact with? Yes, Mr. Ian. You want to try?
Forward.
Say that again.
Forward.
Forward. What do you mean forward? Put it in. I don't know if I asked the question properly, but I think you understand what I'm trying to ask. Naturally, when we look forward, first forward could be I'm looking at him. Is that what you mean? Forward could be I'm looking at the top. As long as I'm looking forward, is that what you mean?
Horizontal to the ground.
Horizontal, that's not the word.
No.
Yes, Jovino.
Parallel to the ground. Parallel
Parallel to the ground. A round of applause for both of them, please. A normal human being does not look at your face if I'm standing. Otherwise, after maybe, 10 hours, I might complain to the doctor that something in my neck hurts me. Because I'm looking abnormally to the way I'm supposed to be looking. But if I look this way, probably wouldn't feel a thing. Our neck, I believe, is designed that way. Look forward. Even when you are sitting down, watching TV, forward. Right? But the moment you do this, playing video game, what do you notice? Your neck pain, right? Or maybe each time you're looking at, some roller coaster or whatever. Each time, what do you notice? Your neck again, right? But the only position you might put your head, like you can position your head at a particular in a particular position, is when you look forward in a plane that is parallel to the horizontal ground. Am I making sense? So normally, a very beautiful picture of myself. Normally, this dude is meant to be looking this way, right? But then, I saw Jenny from our window. Hello, Mr. Daniel. I don't even know if she's going to say hello when she sees me. And I had to look up, right? This is my normal position. The normal way I should be looking, right? And because Jenny said, hello, Mr. Daniel, I have to do what? Look up, which means I'm going to move my neck and deviate a little bit. Am I making sense? Then I'm going to have to deviate a little bit to make eye contact with Jenny and wave back. If I want to wave back. Okay. Then I'll make eye contact with Miss Jenny, who is by the window. You see, this deviation, because this is normal. So this is like my 0 degree, 0, origin, normal stage. Then I have to move my neck up a little bit. That deviation from the original position this angle is called the angle of elevation. That's what we call the angle of elevation. Okay? Am I making sense? And you can see that it's going to end up forming a right angle triangle. If we know my height, and we know the distance to Jenny's building, you can actually find out how high is Jenny to the horizontal ground. Because this is a right angle triangle. And maybe I'm 2 meters away from Jenny's building. It means the base of this triangle is 2 meters. And you have learned SOHCAHTOA. You can find this side, right? And you can add with Mr. Daniel's height. And you can know the height of where Jenny is. That's how it relates to right angle triangle that we have learned. And we're going to do some of this today. Okay? Does this angle of elevation make sense to us, please? So angle of elevation is that deviation from your normal neck position to where you have placed it in order to sight something. Okay? The opposite is the angle of depression. So, let's take another scenario. I'm a soldier working for the Secret Service. I don't know how to draw someone sitting down. Okay, let's say this is me. With my binocular. Watching. Because, let's say President Xi is in the town. And we have to protect him. So, I've been stationed to a particular building. 9 meters is too small. Maybe 50-story building. I am the highest of Macau, checking for the bad guys on the ground. Am I making sense? Normally, if I'm at a point, 50-story building, like 50 floors, I'm supposed to be looking parallel to that 50-story building height. Am I making sense? But how do I catch the bad guys? If that is the only place I look. The bad guys are not the birds in the sky. Okay? Then I saw some dude looking suspicious around here. I'm going to have to bend down, deviate from my original position. Am I making sense? So I'm deviating from here. This is my original position. I'm going to deviate to this position in order to be able to sight that object. I may just report on the radio. Okay, can you guys check out Netanya? I think she's carrying someone's food. She looks suspicious. Do you understand the point? That deviation this time around is called the angle of depression. Okay? Now, in case you are confused, we are all second language students, English as second language students. Okay? Well, most of us. Even you. Your first language is Portuguese, right? Yeah, my first language is Yoruba. My mother tongue. Why do they call it mother tongue? Even though my dad is Yoruba, why is it mother? That's not fair. Why do we have to call it mother tongue? Why not parent tongue? Okay, I need to sue them on behalf of my dad. Okay, anyway.
Who are you gonna sue?
That's true, good question. Who am I gonna sue?
How are you gonna sue them?
I sued the society for calling it mother tongue. Anyway, so, since we are all English language students and we all speak our mother tongue, sometimes it's difficult to remember some of this vocabulary. So, as a lazy student that I was back in the days, I was very lazy. Now, my lazy is not because I don't want to do 100 worksheets. Don't get me wrong. That's not my own definition of laziness. My laziness is that some of these big words in chemistry textbook, can you just spare me and just give me simple words that I can remember? I just want to understand what you're saying. I don't want to memorize those big words. You know there are so many big words. Oh, property of hydro, whatever. Oh, it is very flammable, blah, blah, blah. Can you just tell me it catches fire easily? I understand when something catches fire easily. Don't bring some big, flammable, whatever word. Oh my God, I hate chemistry. Even though the chemistry teacher was like a school dad to me. But I hate the subject. I don't hate him. I love going to his lab. But when it comes to states, how many properties of something, and I have to remember, oh my God. I didn't even grow up in a neighborhood where people speak English. It's like a mini slum. So how am I supposed to learn this vocabulary? There's no library to read books. The only thing a teacher can do for me is to break these words down, and nobody cares anyway. So I devised a means, a lazy means. Is that I look at the tone or the way it sounds, the sound of the word, and I try to relate it to something silly in my neighborhood. And that's how I remember. I'll give you one story. Have you heard about the Newton laws of motion?
No.
There are 3 laws, right?
I don't know.
Right?
Yeah.
Now, those laws I learned in my SS1. My SS1 should be, was it 99 or 2000? Yeah, I think it's 2000. September 99 stroke, June 2000. How many years ago will that be? 21 plus. Right? Or let's say 21, approximately 21 years. And I can still state the Newton laws of motion right now because of my silly way of remembering things. The first law, I always remember football players. And I remember war movies, like all those ancient Greek, Troy, you know, England going somewhere, fighting with maybe France, all those war movies. Somebody fighting in the bush, you know, that's how I remember. Then I would remember if somebody kicks a ball until another football player stops it, that football will continue. Right? The other illustration is quite graphic, so I'm not going to say that. But that one is the only thing that reminds me of the Newton first law of motion, which says a body will continue to be in the state of rest. And if it is in motion, it will continue at that constant speed unless it is acted upon by an external force. That external force is that guy that stops it, or maybe the wind that is blowing in opposite direction. Otherwise, that ball continues. So I remember the war movie. And I remember the football players on the field. Because I don't like to memorize. I'm too lazy to memorize. So I devise means for myself. Once I understand with my means, I can compose it in a simple way. And I'll be fine. After all, you are not asking me to memorize, I should be able to. You just want me to explain the idea in exam. So it's not about Mr. Daniel said I should be able to, and maybe another teacher say students should be able to. The idea is everybody's talking about the objective of the lesson. Are you with me? Mm-hmm. Then the second law of motion says, how I remember the second law of motion? Variation in mathematics. Because I love math. And math has been saving my life since maybe 3rd century. Well, nobody was alive then. Do you get my point? I remember that at the end of the second law of motion, we come up with F is equal to ma. I know A is v minus u divided by t. Rate of change of velocity is the acceleration. I know when I open the bracket, so when I forget stuff, I remember this. I go back to the genesis and I compose the statement. mv minus mu divided by t. And I know that mass times velocity is momentum. mv minus mu means change in momentum. Momentum at the final and momentum at the initial. Right? Anything divided by t means rates. So basically, this is what? Rate of change. I know there was F is equal to kma before k was taken as 1. Before it becomes F is equal to ma later. So how did they get that? Oh, this looks like a direct variation because k is 1. F is actually proportional to mv minus mu divided by t. And I know variation in math. So I remember, oh, the law that I forgot must have been that the force is proportional to the rate of change of momentum. Lesson. Sleepy beauty, wake up. Am I making sense? This is how I remember the second one. The third one, I remember people who believe in an eye for an eye. You steal my water bottle, I throw your pencil case out of the window. Which is not a good thing. Why did I say that? Because the law says for every action, there is equal and opposite reaction. That's what the law says. So when the teacher says that, and they want me to remember everything, I just say, okay, what does this look like in something silly that I've seen in life? Oh, people who believe in an eye for an eye. Oh, you slap me, I slap you back. That's what it means by an eye for an eye. Even though an eye for an eye says what? Who can complete that? Makes everyone blind. For every time I pluck your eye, you pluck mine. At the end of the day, nobody has eyes anymore. They use that to discourage people from believing in that. Okay? So when I was trying to explain it to a friend of mine, he said, oh, how do you use this? I said, okay, I'll tell you. The law says for every action, there is equal and opposite reaction. The action is that he slapped me. Now, my reaction is that I slapped him back. It is opposite because it's going in the other direction now. It is equal because at least I need him to feel how I felt. So if he slapped me with, let's say, 50 Newton force, I'm not going to go back with 5 Newton of force. I'm going to go with 50 and above. Do you understand? Because I don't want to memorize this stuff. But then I come up with a lazy way. Similarly, when I was taught elevation and depression, again, oh my God, here we go again. Another word. What is elevate again? Then, throughout, when you deal with different scenario, when something elevates, it goes up, right? So, oh, okay. So it means the one that, you look up. I know there are two. There are always twins walking around, elevation and depression. Okay, which one goes up, which one comes down? I can always draw the triangle. I can always, I know all that. But I need to be able to interpret my question. I'm saying this as if I know nothing about language. Or maybe I'm struggling with language. So you might pick one or two things that might be useful as well. Depression. Okay, when someone is depressed, their mood is down.
Fair enough.
It's like, oh, their mood is down. Don't think about their jumping down the window. Please don't think about that. Do you understand? So, but that is how I think about it. Just so I can differentiate between the two. Because I'm lazy and I'm a second language student in English. And these things are not taught in my mother tongue. Maybe I wouldn't have worried about these crazy ideas. But they help me. And look at it today. 21 years later, I still stay Newton's laws of motion. And God knows when I was taught this. I can't even remember when I was taught this. And I still remember the idea. Okay? So, just think of smart ways to remember stuff. I call them lazy ways to remember. But of course, it's not like it's lazy. You get the point? So, elevation has to do with that deviation from the normal neck view, to make sure your neck doesn't need to go to the doctor. But the moment you go up, that's elevation, the deviation. If you come down, that's depression. But for angle of depression, because this is parallel to this will be the same as this. Do you agree? Alternate angles. Okay? So, the rest is just to do what problems. So I'm going to write now what I wanted to put in your notebook, and I wanted to put that down. Shall we? cite, when you cite something, you see something. Is that GHT?
Yes.
What? Like this? Okay.
Yeah.
Again, I'm very terrible in this language. Okay, sorry. Oh, actually, I didn't cite an object. I cite Jenny waving at me. How many floors is your apartment?
Let's see.
It's not a floor? Level 9, level 12, level... Which level? 16, okay. So this is Jenny's building. You have a lovely building, Jenny. She's probably wondering, oh no, they told me this teacher is very troublesome. I shouldn't have come to his class. Sorry, it's too late now. So, I have to look up that. This would have been my normal view. So I say normal view. Looking at Jenny. So this deviation from my normal view to that is theta. That is the angle of elevation. Deviates. That's not deviates, is it?
No, building has an L.
What?
Building. B-U-I-D-I-N-G.
Oh. My bad. Really, that was very horrible. Deviate. We'll have to deviate from this normal view by angle theta in order to see J. Here, theta is called an angle of elevation. Right. Hallelujah. Hallelujah. Is that so much? Are you confused?
No, I don't think, no, not yet.
No,
Not yet.
Okay.
Yeah.
I like that. It's like, okay, no one knows tomorrow. But as far as today is concerned, I'm not confused. I like that. It means I still have hope to confuse you.
Yeah, exactly.
Okay. I won't give up. this time I'm sitting on a building. I'm not trying to jump. Don't tell your parent, oh no, our teacher is trying to jump. No, I'm not jumping. I'm just trying to look for Oscar. Okay, I didn't show somebody sitting down. Okay, let's pretend that's me sitting down.
That looks straight.
John, just tell me you're beefing my pictures. Okay, I know you're jealous of these lovely pictures.
No, it's beautiful. I can see this Picasso.
Have you seen
Okay.
It's exactly like that.
Wait, why does Oscar look taller than I am? That's not fair.
It's like
Isn't he taller than me?
No, it's not.
Really?
Really, Oscar, are you?
I think he is.
Okay, so again, this is my normal view. And I'm gonna have to deviate down a little bit to see this dude and say hi. Hello. So this angle is the angle of depression. The angle theta. So let's say the angle theta. For the angle. But of course, if Oscar looks straight, the angle of elevation of Oscar must be the same as my angle of depression for us to make eye contact. Understand that? So this is just the idea. Now let's put it in context. Wait, I'll give you this break. Ah, yeah. Sorry, dude. Please go out for a few minutes. Everyone, let's take 2-3 minutes to walk around.
Finish English yet?
What is this? So core.
What it works, right? You guys start English yet?
Who pick him up?
Oh. Mr. Daniel, you should like move up a little bit. We're like trying to pick you up.
Oh, okay.
Make him right.
What? Bro, what's my thumb? What's my finger? Oh, size him up. The poem, fluffy poem.
If I stand here, I'll look taller than him.
Yeah, you will.
Where should I stand to look taller than him? like him.
Someone Photoshop this.
Someone photoshopping on the fly.
Yeah. Hugh, do your thing.
That. Move.
No star? Yeah, it's new, Lee.
Your nose.
Eat him, eat Mr. Daniel.
How do I eat him?
Go. In front of the
What?
Wait, is this recording still? Okay, well.